Hello, and welcome to the Designing with Love podcast. I am your host, Jackie Pellegrin, where my goal is to bring you information, tips, and tricks as an instructional designer. Hello, GCU students and alumni. Welcome to episode 28 of the Designing with Love podcast. In this episode, I will cover what cognitive load theory is and why it is important in the instructional design field. In addition, I will discuss the science behind cognitive load theory and some practical tips for managing it in your instructional design projects. First, it is important to define cognitive load so you can understand cognitive load theory. Cognitive load refers to the amount of mental effort being used in working memory. It plays a critical role in how people process, learn, and retain information. Cognitive load theory, also known as CLT, developed by Sweller, suggests that instructional design should aim to reduce unnecessary load to enhance learning effectiveness. All right, so now that I have defined cognitive load, let's take a few minutes to review the three different types of cognitive load, which are intrinsic, extraneous, and germane, according to Sweller. Intrinsic cognitive load refers to inherent complexity of the material being learned. It depends on the number of elements that need to be processed simultaneously and how those elements interact. For example, learning basic math involves fewer interacting elements than learning advanced calculus. The complexity is relative to the learner's prior knowledge. Extraneous cognitive load refers to the mental effort imposed by the way information is presented, rather than the content itself. Poorly designed instructional materials, like cluttered slides or confusing explanations, can increase this type of load unnecessarily. Instructional designers aim to reduce extraneous load to free up working memory for learning. Finally, germane cognitive load refers to the mental effort used to process, construct, and automate schemas, which are the mental frameworks that help organize information. Unlike extraneous load, germane load is beneficial to learning and should be optimized, not eliminated, to promote deep understanding. Now that I have explained the three different types of cognitive load, I would like to provide a real-life example of each type and some tips for how to manage it. I obtained these examples from ChatGPT, which is a helpful way to gather information from different industries, since my experience is primarily in higher education and corporate training. A real-life example of intrinsic cognitive load is a medical student who needs to learn how the human heart functions. The heart's anatomy and the process of blood circulation involve many interrelated components. Therefore, even with well-designed materials, the content itself is complex, so the student naturally experiences high intrinsic load. The best way to manage this scenario is to scaffold learning by breaking down the system into smaller parts, such as focusing first on the heart chambers, then on the blood flow pathways. This type of approach ensures that students do not become overwhelmed with the content and can understand and retain each function of the heart before putting all the pieces together. A real-life example of extraneous cognitive load is a training session on software that uses cluttered PowerPoint slides filled with tiny text, multiple fonts, and unrelated images. Due to this, the learner has to work harder just to understand what's important, which ends up wasting mental effort on things unrelated to the actual learning objectives. The best way to manage this scenario is to use clean, well-organized slides with consistent formatting and only incorporating essential visuals to reduce extraneous load. On a personal note, I have actually encountered scenarios similar to this before in my current role, when subject matter experts have sent over lesson presentations with cluttered slides that contain too much text, multiple fonts, and unrelated images. Although it takes work and effort to make the improvements, it is well worth it to ensure learners do not experience extraneous cognitive load. A real-life example of germane cognitive load is when a math teacher asks the students to solve a real-world budgeting problem after learning about percentages. In this scenario, students must apply their knowledge and organize it into a usable framework, which promotes deeper understanding. The best way to support this type of learning is to include practice opportunities that require critical thinking and reflection, such as case studies or problem-solving tasks. This is an example of germane load, which is beneficial for learners and should be encouraged. Now that you have a solid understanding of cognitive load, I will provide a brief overview of cognitive load theory by explaining how our brains process information and the role it has on working and long-term memory. According to Richard Atkinson and Richard Schifrin, our brains process information through a system of sensory memory, working memory, and long-term memory. To begin, sensory input first enters sensory memory, and if it is attended to, moves into working memory, which has a limited capacity and temporarily holds and manipulates information. With effective coding and rehearsal, information can then be transferred to long-term memory, where it is stored and organized for future retrieval. According to Alan Badley, working memory plays a critical role in learning by holding and manipulating new information in the short term. However, it has limited capacity and duration. For learning to be effective, information must be organized and coded into long-term memory, where it can be stored more permanently and accessed when needed for future tasks or problem solving. All right, so now that you have a good understanding of how our brains process information and the role of working and long-term memory in learning, I will take a few minutes to explain why understanding cognitive load is crucial for instructional designers and the impact it has on learning outcomes. So, why is it crucial for instructional designers to understand cognitive load when designing instructional solutions and learning experiences? Understanding cognitive load is crucial for instructional designers because it assists with creating learning materials that align with how the brain processes information and avoiding overload that can hinder learning. By knowing how to manage intrinsic load, minimizing extraneous load, and promoting germane load, designers can craft experiences that are more engaging, efficient, and effective for learners. In turn, this leads to better knowledge retention and skill development. Next, I will briefly describe the impact of cognitive load on learning outcomes. Cognitive load directly impacts learning outcomes by influencing how well learners can process, understand, and retain new information. When cognitive load is too high, learners may become overwhelmed, which leads to confusion and poor performance. By effectively managing cognitive load, this supports deeper learning and improves the transfer of knowledge to real-world situations. Next, I will provide two specific examples of instructional design strategies that consider cognitive load. The first example by Richard Mayer and Roxana Moreno is a strategy called segmenting, known as chunking information. This strategy involves breaking complex content into smaller, manageable segments or chunks that learners can process one at a time. This helps reduce intrinsic load by allowing learners to focus on understanding one concept before moving on to the next, which is especially helpful for novices. A real-world example of this is in an e-learning module on data analysis, where you can present steps for using a software tool in separate short videos instead of one long tutorial. The second example by John Sweller and Graham Cooper is a strategy called worked examples. This strategy provides learners with fully solved problems and examples before asking them to solve the problems on their own. This helps reduce extraneous load and supports germane load by helping learners build schemas through observation before engaging in active problem solving. A real-world example of this is in a programming course, where you can show a fully annotated code solution before assigning a similar coding challenge. So now that you have two real-world examples of how to manage cognitive load in learning, I will outline 3 evidence-based strategies for reducing extraneous cognitive load, techniques for managing intrinsic cognitive load, and methods to enhance germane cognitive load for better learning. When deciding what to share with these practical tips, I used ChatGPT to help me, while also incorporating scholarly sources to support the strategies, techniques, and methods. First, I will start with the strategies for reducing extraneous cognitive load with an example of how each one can be used in practice. The first strategy is to eliminate unnecessary information, also known as the coherence principle from Ayres' 12 Principles of Multimedia. This strategy involves removing any extraneous text, images, sounds, or design elements that do not directly support the learning objective. The reason why this strategy works is because irrelevant material distracts learners and takes up working memory. An effective example of this in practice is to avoid decorative images or background music in a training video, unless these elements serve an instructional purpose and enhance learning. The second strategy is to integrate text and graphics, also known as the spatial continuity principle from Ayres' 12 Principles of Multimedia. This strategy entails placing explanatory text close to the visuals they describe, rather than separating them on a screen or page. The reason why this strategy works is because when learners have to mentally integrate information from different locations, it adds unnecessary effort and cognitive load. An effective example of this in practice is to place labels directly on parts of a diagram rather than in a separate legend or paragraph. The third strategy is to use modality wisely, which is known as the modality principle from Ayres' 12 Principles of Multimedia. This strategy involves presenting verbal explanations as audio narration rather than on-screen text when also showing visuals. The reason why this strategy works is because it takes advantage of both the visual and auditory channels in working memory, which reduces overload in the visual channel of the brain. An effective example of this in practice is in an animation showing how a machine works, by using voiceover to explain rather than displaying subtitles with the explanation. Next, I will review the techniques for managing intrinsic cognitive load and how each one can be used in practice. The first technique is to scaffold learning by sequencing from simple to complex, by presenting material in a progressive sequence, starting with the simpler concepts and gradually increasing complexity. The reason why this technique works is because it helps learners build foundational knowledge before tackling more complex ideas, which reduces the mental burden at each step. An effective example of this technique in practice is to teach basic grammar rules before asking learners to write full essays in a language learning course. The second technique is to use pre-training to build prior knowledge by introducing key terms, concepts, or components before diving into the main lesson. The reason why this technique works is because pre-training helps learners activate or build relevant schemas, making it easier for them to process more complex content when it is introduced. An effective example of this technique in practice is before teaching how an engine works, first explain the function of each major part. The third technique is to chunk information into meaningful groups by organizing content into logical chunks based on themes or processes to reduce the number of elements learners must engage in at once. The reason why this technique works is because chunking simplifies cognitive processing by allowing learners to treat multiple elements as a single unit. An effective example of this technique in practice is to group related vocabulary terms under a common theme, such as food or travel, rather than listing them randomly. Finally, I will outline the methods to enhance germane cognitive load for better learning and how each one can be used in practice. The first method is to encourage self-explanation by prompting learners to explain concepts or problem-solving steps in their own words during or after instruction. This method works because self-exploration helps learners actively process and organize information, which strengthens their schema construction and long-term understanding. An effective example of this method in practice is after watching a demonstration, ask learners to write or say why each step was taken and how it connects to the next step. The second method is to use varied practice with reflection by providing practice activities that require applying knowledge to different contexts, combined with opportunities for learners to reflect on what was learned. This method works because it promotes deep processing and helps learners form flexible mental models that can be transferred across different situations. An effective example of this method in practice is in a customer service course, having the learners handle different types of client scenarios, and then reflect on the communication strategies used either in a written format or among their peers. The third method is to incorporate problem-based learning, known as PBL, by designing activities where learners solve real-world problems that require applying knowledge and reasoning skills. This method works because PBL engages learners in active, meaningful learning, which encourages deeper processing and integration of new knowledge with existing schemas. An effective example of this method in practice is in a health science course, by presenting a realistic patient case study that students must diagnose and treat based on prior learning. This activity can be completed in a simulated lab setting or through a check for understanding branching scenario where students are provided with a case study. I hope you have found this information about what cognitive load theory is and why it is important in the instructional design field helpful as you work on future instructional design projects. I realize that there is so much valuable information shared in this podcast episode that you may want to reference in the future as you work on your future instructional design projects in your courses at GCU and beyond. Therefore, I have developed a handy guide that you can view and reference in the show notes. As a recap, we covered the different types of cognitive load, the science behind cognitive load theory, the impact of cognitive load on learning outcomes, and some practical tips for managing cognitive load in instructional design. For your next project, I encourage you to apply the tips and strategies discussed in this podcast episode in your next project and see how it goes. You are welcome to text me and let me know how you have found cognitive load helpful as you design and develop your projects. As I conclude this episode, here is an inspiring quote about why education is important by Dr. Seuss. The more that you read, the more things you will know. The more that you learn, the more places you'll go. Thank you for taking some time to listen to this podcast episode today. Your support means the world to me. If you'd like to help keep the podcast going, you can share it with a friend or colleague, leave a heartfelt review, or offer a monetary contribution. Every act of support, big or small, makes a difference, and I'm truly thankful for you.